So Venn diagrams is another way to represent probabilities and events. So here's an example. It says use a Venn diagram to represent an event of getting 2 or 5 when rolling a die. And here are the steps. Step number 1 is basically draw all possible or list all possible outcomes inside of the box. The box represents the sample space. So what are the outcomes? 1, 2, 3, 4, 5, and 6. These are our all possible outcomes. That's our sample space. Step 2, in one motion, draw a shape around the ones that are in the set description of the event. So for our event, we're getting 2 or 5. So we're going to circle 2 or 5. That's going to be our event. So the Venn diagram has the following properties. As we already mentioned, the entire box represents the sample space, and the area of region represents the event. Let's take a look at this example. It says, suppose you were offered the following bet. You put the $10 on the, and the other person puts up 5, and you flip a coin 2 times. If you get 2 tails, you lose. Use a Venn diagram to describe event in which you lose. So what is our sample space? So you can get 2 tails by flipping twice, right? You can get tail and head. You can get head and a tail, and you can get 2 heads. So that's your sample space. Goes in a square. So in which event you win? Oh, it says use Venn diagram to describe event in which you lose. So you do not win, and you win when you get 2 tails. So this is the event that you win, and the rest is when you lose. So let's talk about another concept, very important concept in probabilities, such as complementary events. Event A, denoted by A with a bar above it, or A with an apostrophe like this. And it consists of all outcomes in which the event A does not occur. Okay, so if we refer to our previous example, we could have event when we win. That's event when we get 2 tails. In any other case, we don't win. So don't win is a complement of winning, and vice versa. So here's a meme that I picked. I thought it was funny. It says 2 books. One book says, would they teach you at Harvard Business School? And a second book is a complement to it. It says, what they don't teach you at Harvard Business School. So both of these books are supposed to cover everything, all the knowledge in the world. So the complement and the event and its complement should cover all possibilities in the entire sample space. So let's formalize it. Rules for complementary events. The total area of the square is 1. So in other words, the probability that something will happen, either the event or its complement, is 1, or 100% chance. Well, if probability of event A has is known, then the rest of it is the probability that that event will not happen. So probability of a complement is 1 minus the probability of the event itself. And together, probability of A and not A equals to 1. And that's the probability of a sample space. Now let's apply this knowledge to this example. It says you're planning a 2 p.m. flight to San Francisco on Friday. The probability that the plane will take off on time, denoted by L, is 85% or 0.85. What is the probability that it will not leave on time? So since L is the probability that the plane will leave on time, and we know probability of L is 0.85, then the probability of not L is going to be 1 minus probability of L, and that's 0.15 or 15% chance. So together they should make 1.